All right, there's one operation that we have on functions that we don't have on numbers. Like if someone gives you two numbers, you can add them, subtract them, multiply, and divide. But with functions, we've seen we can do the same thing, add, subtract, multiply, and divide. But there's something else called composition. And that's something we can do with functions and we cannot do with numbers. And here's an example. We're given two functions. F of x is 2x plus 5. G of x is 3x squared minus 4. And we're asked to find the composition f of g of x. So the little o here is what tells you this is composition. So don't get that confused with multiplication. Now, by definition, okay, what I mean is the way that this is defined is that you start out with f, and inside of f, you put g of x. So g of x, this function, is going to get plugged into that function. So that's why g of x is inside of f. So just notice the use of my parentheses and things here. Now, what I do next is I write f, and then inside f, what are we plugging in again? G of x. Well, what is g of x? Let's just write it down. That's 3x squared minus 4. Okay, now the tricky part. The tricky part is that this right here is going to go into f wherever we see an x. So that x right there is going to get replaced by that entire expression. So I can drop the f now because I'm plugging in. I write 2. Now what's plugging in? Well, this thing. So I put parentheses, 3x squared minus 4, and then what comes next? Plus 5. Okay? So that's kind of like the 2x plus 5, but instead of x, it's all this stuff. Now distribute your 2 through. That'll become 6x squared minus 8. Okay, that's here and here. Then plus 5. And then now just put these two together, you get 6x squared minus 3. So the composition of those two functions, f of g of x, is equal to 6x squared minus 3. So if someone now asked you to find f of g of, let's say, 3, all you would do is plug 3 in here. 3 squared would give you 9. 6 times 9 is 54. Minus 3 would give you 51. So you just plug that number into that. Okay, now let's see the difference between doing f of g of x versus this one, g of f of x. So the difference here, and I'm going to erase this, is that g is sitting on the outside, and inside of g is f of x. Okay, so what that means is I'll leave the g alone, and inside of g, what are we going to put? F of x. Now, what is f of x? It's this. So 2x plus 5. And again, this is the tricky part, right? This is where you say, okay, on my g function, I'm going to plug something in. Now, what am I going to plug in? Well, not x. I'm going to plug all this in. So all of this is going to replace that piece right there. So I write down the 3. Then what's getting plugged in? 2x plus 5. Now, what is that? What happens to it? It gets squared, and then minus 4. Okay, now that's a sufficient answer, but what we'd like to do is expand this out. That means square this, and then kind of clean everything up. So let me do that right up here. First of all, let me do a little scratch work. 2x plus 5 squared means 2x plus 5 times 2x plus 5. Now I'm going to FOIL. Here to here gives me 4x squared. Here to here gives me a positive 10x. Here to here gives me a positive 10x. And then here to here gives me 25. I put these two middle terms together. I get 4x squared plus 20x plus 25. Now this right here is just this squared. So we still have a 3 in front of it. So back to my answer. So I'm continuing my answer here, equals this. 3. Now, what was this squared? All that ugly stuff over there. 4x squared plus 20x plus 25. Now, what do we still have in our function here? We did this squared, we had the 3 in front of it, and now we still have minus 4. Okay, now distribute the 3. So the 3 is going to get distributed. We'll have 12x squared. Here we have 3 times 20, which gives us a 60x. Then here times here gives us a plus 75. And then don't forget the minus 4 at the end. And that's the last thing we have to do is put these two guys together. So 12x squared plus 60x plus 71. So that is the composition g of f of x. And you can check if you look back or rewind the video that f of g of x was not the same as g of f of x. They came out to be two different functions. So now if someone wanted you to do g of f of, let's say, 3, you would just plug 3 in here, square it, multiply, plug 3 in here, multiply it, add everything together, and you get your result.